So, welcome everybody. Welcome to my talk. I am Maia. I'm going to be talking about Jetpack Compose, another talk about Jetpack Compose. My talk is titled Something Old, Something New, Adding Jetpack Compose to a Large Open Source App. You'll notice there I've got a cautionary tale. So this is an adventure of how I added Jetpack Compose to an app and the things I found on the way. Who am I? I'm Maia, and I work at Luno. And if you need to ask me questions afterwards or get hold of the slides, that's my Twitter handle. So what am I doing and why am I doing it? Well, I'm an Android engineer, and at the moment, Android engineers are learning Jetpack Compose. And so I decided I wanted to learn Jetpack Compose, but I didn't want to learn it in a Hello World app. I didn't want to learn it in another to-do app. I wanted something that was more realistic, something that had some experience and that was a slightly larger code base. Also, I'm using this to-do app. It's called Habitica. It's a gamified to-do app. So how it works is you give yourself tasks to do, to-dos or dailies or habits that you track, and then when you complete them every day or when you complete your tasks, then you get experience and gold. If you miss your tasks in a day, you lose health. So it's a gamified version of a to-do app. What's more important, though, is that this particular app has many installs and has got quite a few stars on the Play Store. But even more important than this is that this whole app is completely open source and all of the source is on GitHub, which means it's a perfect example app for me to use to add Jetpack Compose. Also, I have to be honest with you, I am a completionist, and I have every single badge in this app. The one badge I am missing is the contributor badge. Now, the only way you can get a contributor badge is if you put a PR up, they accept your PR, and you give them your ID, and then you can get this badge, or if you make an image, or if you write some stories. So I have a second agenda. Yes, I want to learn Compose, but actually, I want the contributor badge. So let's just have a look at this app. You can see here it started in 2012, right? So it's quite an old app. You can see there are the contributions, different people's contributors adding code. And I suspect that many of these are also people who want the badge, right? People who are making a particular commit to the PRs, to the app to get the badge. Also, before I started, I wanted to have a look at what did the app look like? What was the architecture like? Would it even be possible? What would it be like? So, looking at the app, there are 26 activities in this app. Are your hairs on your arms starting to go up? There are 33 fragments, right? A mere 12 repositories, slightly worrying, only 7 view models, and 13 view holders. So what I can see from this, just from these numbers, is that it's a complex app, right? There are many screens, there are many moving parts, there are lots of different things happening. It's not just a one-screen or a two-screen app. I suspect there's some kind of architecture happening because there are view models and repositories. But given that there's so many activities and I don't really see any other classes around, I suspect that a lot of the business logic is sitting inside the activity. That's just my hunch from opening the project and looking at it. So, my first reaction at this point is it's going to get messy. This slide is important too, because you see this monster, it's made out of junk food. And part of the gamification of this app is that you pick the tasks that you want to do, and then you get challenged by a monster. And if you do your tasks, then you hit the monster and the monster dies. But if you miss your tasks, then the monster can hit you back. The other reason I have this slide is that all of the images that I'm using in my talk come from Habitica, and they're open source Creative Commons license. So you can find these images by the great artists of Habitica on the internet. So I'm taking a step back, and I'm looking at Compose, learning about Compose, trying to see how am I going to put this into the architecture. Now, The one thing to note about Compose, it's got this unidirectional state flow, which means the state goes to the UI, and then events bubble up, and if something changes in the UI, then the state needs to get updated like that. The other thing to notice is this architecture is the architecture from typically the architecture guidelines. So you would have one or more activities, fragments, view model, repository. Your app might not look like that. I know that this Habitica app does not potentially look like that. In the old world, there was XML here. So where in this picture does Compose fit in? So Compose fits in over here. It means the state that's coming from the network or from a database, gets hooked to the UI through Compose. So it replaces the XML. So what this means for me, this image means for me in the Habitica app is that this architecture can stay the same. If I can find the spots in the code where I have this happening, the state and the UI connections happening, that's the place where I want to swap out the XML and swap in the Compose code. So let's just look again at how Compose works. Now, if you've studied Compose a little bit and you've tried a few things, you probably know this. But I'm going to go over it again because there are a few little things I wanted to highlight. So how Compose works is you have a function, a composable function, that takes in state from its parameters. You could set it by remember, but the idea is that you want these stateless composables. So this function calls these functions, and depending on the logic, might build up a tree of composables, of nested composable functions. And if you're writing a composable function, how do you do it? You put this annotation at composable, and then it's just a normal function. There is a convention to have the first letter capital. You pass in the state. But this at composable, what it does, in fact, it's a compiler plugin. And at compile time, what happens is you get this composer object being passed in as one of the parameters. I mentioned this, that this is a compiler plugin. You'll see later on why that is important. The other thing about the composer is it has a way of knowing what the state is. It has a way of figuring out where the state changes. And it can decide, depending on how the state changes, to redraw or recall these composables, which will then re-emit your UI. So that's the basics of Compose and how it works. So further research. So given the idea that I want to take an existing app with lots of code, how am I going to put Compose into that existing app? I did some more research, and you'll probably have seen in the documentation, if you've got classic XMLs, there's an XML Compose view, and then in code, you can set the content. So that's how you add Compose into existing XMLs. If I've got some XML view over here that I want to put inside a composable, then you use the Android view, and there's a factory for that. So there's a way from this, I'm learning, that there's a way that you can easily interoperate and put pieces of Compose into XML and pieces of XML into Compose. There's also pretty good view model support, and then I also read about a theme converter. So now this is interesting. So what it means is if I've got a big app, it's already got a theme, right? I've got somewhere where it's setting up the colors and the styles and everything, and I want to be able to take that theme and also use it inside my Compose world. So I was very excited to read about the theme converter. At this point, I also created myself a starting character in the Habitica app, because I'm going to use this starting character as my test character to see the work that I'm doing in Compose. So I've got the character, and now I've got a plan. My first step is to write my plan down as a to-do. So here you'll see, get the repo, sort out the build, figure out how the themes work, add a composable, add some tests, put the PR up and get the badges. Now, anybody who's done any planning in any project knows that these checkboxes are not all the same size, right? I mean, get the repo and fork, that's pretty quick. But here, add a composable, maybe that's not going to be that easy. Testing, don't know. So it's a plan at least. I've got something to start with. Now I've got to start. So my first monster I encounter on this journey is laziness and vice. So I have to get myself motivated to work and to add the composable elements to this thing. So I've got the plan, I need to follow the plan, but for an extra accountability during the path while I was doing this, I made a Twitch channel and I would record 2 hours on a Tuesday, me trying to add Compose into the project. So laziness and vice sorted out. We are on a good roll. We're making progress. So I pulled the repo and I tried to put Compose, add the Compose dependencies. The first error that I get is this one. So these are feral dust bunnies. This is my second monster. So you know about dust bunnies, those things that live under the couch, and you sweep them away, and then tomorrow you get back there, and there are more dust bunnies. Somehow dust bunnies are always there. And with the Compose project, these feral dust bunnies, every single time I either updated to a new version of Android Studio or something, I changed something, I would keep getting this error which says that I've got to fix my configuration. Luckily, dust bunnies are easy to clean up, and the error message is actually pretty clear. It tells you. And the reason that you get this is because that @composable is a compiler plugin, which means your Compose version and your compiler version needs to match. If they don't match, then there's a problem, then you can't build. What I have to say, since I did this project, the Google team at the end of last month have started decoupling the versions. So at the moment, there's a typo here. That shouldn't be 1.6, that should be 1.7. But you can change your Compose plugin with your Kotlin plugin, and the rest of your libraries will be backward and forward compatible. And the first version that they've decoupled is the Compose plugin. So this is an improvement of the dust bunnies. But at the time when I was doing this, there was really tight coupling, and I kept running into this problem. But sorted out, my project is building, I've got a composable in my project. What was my next step? Now, my next step was to start looking at the themes. And my intention was to have a single source of truth. So if you think about a big app with lots of themes and lots of things happening, you want to define your colors and your themes in one place, and then you want to share this between your XML and between your Compose world. And I was going to use the MDC theme because this particular project used material. And what this gives you is that if you use this converter, it will look at the theme that's in the context, and it will give you the colors, the shapes, and the typography of the particular material theme. Sounds good. Okay, what do you get? Well, the material theme gives you these colors, not very many. It gives you a font family, and it gives you shapes. But it's something you can work with. However, when I looked at this particular app, this is what the theme looked like. There was day and night mode, not a problem. The Compose theme converter can handle day and night mode very easily. It was derived from material theme. Okay, that's great. The actual app theme derived from material theme was not using the font families at all, nor was it using the shapes. So the font families and shapes that I would get from the conversion would be useless to me. So I wouldn't even need that. In addition, they had 27 custom colors. So apart from those 11 material colors, I had another 27 custom colors I needed to add. 82 styles. Now, styles isn't even part of the theme. In Compose, how you do the styles is you do the styling on a particular composable, and you create a composable that has that style. There were many other colors that were used in fixed places in the code. And then they had an additional thing where you could have a red, maroon, orange, yellow, green, teal, or blue version of this theme with 16 more colors. So clearly from this, I have another monster. This one doesn't look so scary. It has got 2 heads, so I thought this was an appropriate one because it had the XML head and the Compose head and all these colors in the tail. And in reality, I had to let go of the idea of a single source of truth because it would be too complicated to just convert all of these colors into the new theme. There is, however, pretty good documentation on how to build a custom theme. So looking at that theme, I would have had to either take a material theme and add something, or I would have had to make my own custom theme. Now, the way that the themes do this is they have a composition local. So if you think about these functions calling down and the state coming in as parameters into these functions, you don't pass all of your theme colors or your fonts or your styling in as parameters. That would be actually large and cumbersome. So the way that the Compose team have solved this is they provide a composition local that if you say wrap this in a theme, you get the composition local with the theme colors. And so what you would do if you have custom colors is you would add custom colors into the composition local. Now, I don't know about you, but this composition local, it feels a little bit like global variables. I mean, it's not a global variable like it's all over the app, but it's like you're in a function at the bottom here, and then magically there's a color that you're going to be able to get out of the composition local, and so you kind of need to understand that. It's not like it's a functional, pure functional call where you can see all of the inputs coming into the parameters. So my sense was, yes, composition local, definitely a good idea if you need it for this kind of thing, but preferably not. I wouldn't want to store all of my variables in there. So another way of seeing this, another diagram, is there's a composition local. And when you're building a theme is just a composable function. Inside your composable function, that's your theme, in this case the Habitica theme, I had a brand accent color. And then I tell this composition local provider that I want to keep this or store this brand accent inside a composition local. And then there's a singleton object with the same name as this function. And somewhere inside those functions down at the bottom, you access it like this in a static way. So that's the second diagram. And I'll just quickly show you the code. Now, I know it's after 5, and I know no one can read code anymore, but it looks like this. I'm showing you this so that you can see the words and that you can search in Google for it later. So here, I'm setting up these extended colors. This is the theme. Here, I'm telling the composition local provider that if someone asks for local extended colors, then they must get it from here, and you can set the color in here. And this is how, in the singleton object, when you need the color, you can get the current version of the local extended colors. Okay, so now I've got the theme sorted out. I know how I'm going to do the colors. Now I look at the packages inside this app, and I'm trying to decide where am I going to put my composables. Now, I could make a package that just has all the composables in it, but that potentially was going to be a big mess again with everything in the same place. So what I chose to do was I created a separate model for the design system. Now, this is part of, that app was not modularized, and one of the reasons I tried to do it like this was because I was hoping that while I was doing my Twitch channel, I kept having to wait for the Gradle build when I was doing any of the Compose things, and I was hoping that I would get my Gradle build loop quicker so that on my Twitch channel, I didn't have to watch Gradle build as much. So what I did for this project was, I have all my components, I have all my themes. These are the reusable components living in this design system module. And then inside the app, they had fragments activities. I added more screen-specific components like this. Now, this isn't a very pretty breakdown, but this was just working with the way the packages were in this app. I think if I were to suggest to the developers of this app, with what they've got, what I would propose was that the features start being in their own packages so that potentially you could split these out in different modules. I would keep the design system here maybe, and here, this composable is compose code. I would put any screen-related compose code in the same place where the view model was, so that you've got your composable screen over here, but then keep separation and have reusable components living outside in this design system module. So now I've got the theme sorted out, and I kind of know where in the packages I want to put my code. So the Compose documentation suggests one of two approaches. They say you can either take a whole screen and convert the whole screen, or you can take it component by component. So my first experiment, I tried the whole screen approach. I took the About screen, I built these buttons over here, and the links, and then I built the whole of the screen and swapped out the XML About screen. And you can see here, these are the samples. The theme is working perfectly. You could change the colors. So this monster, this Triceratops, wasn't too bad. I managed to get a whole screen built pretty easily. And over here, you can see there's an Easter egg. So if you click on the version number a few times, it starts up this particle system. Now, the particle system lives outside in the fragment. and this whole screen is Compose. So what you can see from this is that it's quite possible to take a fragment with all sorts of other code happening and just drop in a whole screen of Compose into the fragment or activity. So this one was actually quite an easy monster to beat. And after doing that, I was at level 4. I had a new hat with horns and a new sword. I was making progress. So then, after I did the whole screen, I decided, let me try out the component approach. Now, I could have just taken a button and dropped a button in, but I wanted to try something slightly more complicated. So what I've got here, this is a to-do item, but these to-do items have got sub-elements, and if you click on this gray box, it opens this up and closes it up. So there's some kind of state here that knows if this should be open or closed, or if there aren't any sub-elements, then this gray box is not there. So I set out to build this component and to see if I could put this component inside this recycler view. I also managed to find some good documentation on how to put compose views inside a recycler view. So I built this, and I have to say it was pretty easy to put it together. I could put this complex component together with just surface, box, column, row, checkbox, and text. So not a lot of complicated things. I could build this and put it together. And it looked something like this. So I had a to-do card composable with a surface inside, which I think I had only to get the corners round. And inside that, I had the to-do body. Now, the to-do body was clever. It knew if this was expanded or not. So it had a state that it remembered, and then the checklists as a list below. So that was the to-do body, and then if you break that down even more, oops, it looked like this. So I had a column because these pieces are one below the other, and I had a row over here because these pieces are put together horizontally. And then the checklist, there was just an if code to see if it needed to show it or not show it. And the experience of building this was also relatively easy. I could open up the XML and get the preview. This is a snapshot of what my IDE looked like. And in parallel, I could write the compose code and see the two side by side, and in that way, build up my component from XML, translating into compose. So now, I have to take this component, and now I have to build it back into that screen with the recycler views. So this is a simplification of what that architecture looked like. There's a fragment, there's a repository, no view model, no other logic, so a lot of logic here. There's a realm database. They're using RxJava, hooked up to an adapter with a recycler view, and there's a view holder over here. So inside the adapter, the view holder here, this is the place. So if you imagine that diagram that I had with all the architecture and just swapping out the state to UI connection, this is where the task object that I'm getting from this realm database, the state, if you like, gets hooked into the XML. So this is the place where I'm going to swap compose in. And so that means I wrote a new view holder that could handle compose. That was also pretty easy to do. This is what the bind method would look like. You get this data in here, and then this view holder has a compose view. You just call set content. So this should look familiar to anybody who's done any compose. You call set content. There I'm setting the theme, and there's my to-do card composable function that I created. There was a little bit of conversion here to populate that to-do card. Okay, I've got a view holder, and now I need to put that view holder inside the adapters and the recycler view. So there's a book by Martin Feathers called Working Effectively with Legacy Code. And there's a whole chapter in the book about what do you do if you don't understand the code well enough to be able to change something. And what he suggests is that you start drawing some diagrams. Any format. They can be UML, they don't need to be UML. And this is the start of my diagrams that I tried to figure out how all of these adapters and view holders and recycler views in this app all fit together. And here I came across the biggest monster that lives in the realm of the void. So in the story, she lives in the realm of the void, and I thought it was very appropriate because there's a realm database in here, and things just kept going around in circles and circles for me to try and figure out how I would be able to add this new view holder that I had inside this app. So the purple is the new stuff that I wanted to add. The other pieces that are there, you don't need to understand it, but what you can see here is that I've got multiple inheritance with find view by IDs in different places. And the find view by ID is problematic because if you've got a compose view holder, there is no more find view by ID. So I couldn't put this view holder in at the bottom of the stack. I had to find the spot. And this recycler view adapter, this was using generics that had, so I had to make an interim level here and then inherit like that. I could clean all of this up. But the problem with why it was having all of this inheritance was that these classes were used all over the app. So if I changed any one of them, I could potentially break any manner of other screens all over the app. So you can clearly see there is some coupling here. However, I did manage to do it in the end. So on the left here, you can see there's the component in the recycler view. If you click it, it snaps open. But that was kind of jarring, that snapping. So I decided to add a little bit of animation. So here you can see it takes 3 seconds to open up and show the checklist items. At this point, my experience was that it was actually pretty trivial to add the animation. It was actually quite easy. I'll show you what it looks like. So I had a state that knew if that checklist was expanded or not. And that to-do body that we saw earlier, it passes the state in of whether the checklist is expanded or not. And if you click on the little gray box on the side, it would just change the state. So that's the original code. To add animation, all I need to do is to add this animate content size modifier. And that would just add the animation. So it would just make it animate with all of the default animations. Then, because I was making slides, I wanted the animation to be a little bit slower so that you could see it on the slide. And that is as simple as just giving it a different animation spec. Now, tween isn't the best you can do. You can be quite complex in the way you animate. But literally, one line of code, and the complex component was animatable. And at this point, I reached level 6. I got a new background. I have this nice griffin pet. And I happened to do it around Pi Day. And in this app, if you're doing things on Pi Day, you get this hat that's got a piece of pie on it, and this shield with a pie on it. So I was definitely making progress. So if you remember my plan, the next step was write some tests, put the PR up, get the badge. None of the existing tests compile. Yes, I could make a test for that specific component and put that up, but I mean, just the way that the tests were, it felt like, and at that point, you can see I'm hesitating. At that point, I had this real implosion, and I was thinking, if I were the developer of this app, and I received my PR, would I approve it? Would I even give the person the badge? They're not adding any new functionality. They're not making it better. They're making the hierarchies more complex. I mean, what is this PR worth? And I remembered another quote from this book by Michael Feathers. What does it matter whether I make this little piece nicer if 90% of the time I'll still be working with murky slime? Now, I have to give a caveat. It felt like murky slime to me because I didn't know the code base. And maybe the person who's used to writing in that code, it doesn't feel as bad for him. But for this particular PR, I just felt like this is not helping anybody. It's a good experience and it's a good experiment for me, but it's certainly not helping anybody. If I look at the app that I am working on my day-to-day basis, there we're busy cleaning things up all the time. We're busy refactoring. Yes, we have pockets of murky slime. All apps have pockets of murky slime. But if you're continuously cleaning, like you're cleaning up the dust bunnies, then eventually it does get better. It does get cleaner. It does get easier. You can add tests. So it does matter, and you should be cleaning up the murky slime, but not if it's just one PR that's like an isolated slice that I'm trying to put in. So did I get the contributor badge for this? I did not. I did not even put the PR up. I felt that that particular app actually has a whole lot of memory leaks. What I should do is, after this conference season is past, I should take a few weekends and clean some memory leaks, and rather get my badge by cleaning memory leaks and not by putting Compose into this app. So the question is, should you put Compose in your app, or why would you put Compose into your app? Would you do it for the buzzwords, right? Declarative, intuitive, quicker. We don't know. Those are just like buzzwords. I wouldn't be able to say if it's going to be quicker or if it's going to be intuitive or if it's... And declarative sounds nice, but in practice, I don't know yet if that's going to be a good idea to put Compose into your app. However, what I can say from my experience is that it's really easy to build a little test for a component. So if you think about an XML app with a recycler view and view holders, if you just want to test that little view holder, how would you even do that? Or, I mean, tests, I've seen tests with recycler views. Those are pretty complicated to write. Now, with Compose, I can break those down, and my components are more testable. So if I can test those small components, it means I've got a quicker feedback time. So there's faster developer feedback from a testing perspective. The other thing is there's live edit in Android Studio. So I'm getting quicker feedback with live edit and interactive previews. So the whole experience of creating a composable, there's a quicker feedback time, and that for me is like I get a lot of satisfaction. If I build something and I can see it work, and I can build something and I see it work. So that would be a benefit for me and a reason why I would consider putting Compose into the app. And some things are easier. Thinking about unidirectional data flow, I can see that it can fix some strange race condition kind of bugs if you change the architecture and you do that properly. The animations are super easy. The theme switching was really easy because in the old way of doing things, you had to restart the whole activity to get the theme to switch. And with Compose, you can just switch the themes. And theoretically, if I'd converted all of the recycler views and all of the adapters to just lazy columns and lazy rows, that would have improved the app as well, because it would be a lot of boilerplate that I could remove from the app. So that would be another reason, a tangible reason, why I would consider putting Compose into an app. And then there's the reduction of the cognitive load. So Compose is in Kotlin. What this means practically is that I don't have to mentally switch languages. If I can have everything in Kotlin, if I can have my builds scripts, KTS Kotlin files, if I can have my UI in Kotlin and all of my code in Kotlin, it's like I only have to load one language into my brain, and that means that context switching, I get less of a context switch. And that would also be a reason why I would consider putting Compose into an app. So now, what did I learn from this whole journey? So what I'm going to do now is I'm going to go through the monsters, but I'm also going to kind of compare it at the same time, this app, but also the app that I work with on a day-to-day basis and how that compares. Now, the first monster were the dust bunnies, right? The Kotlin versions. Now, this isn't such a big problem, and given that my current day job app, we've already updated the version, so this might potentially not be a big issue. And also, the way that they're decoupling the libraries, this is also becoming much easier to deal with. The second monster was, where do we put the packages? Where do you put things? And so my recommendation there, or the way that I think it works there, is that if you can split things into modules that encourage people to reuse, because you want to be able to reuse composables, and then keep other composables that are screen-specific with the screens. So that would be, but I would say before a team starts using Compose, it's probably a good idea to decide where you want to put these things. Otherwise, you're going to have them spread out all over your app, and it might be a bit complex. Then screen versus component. So even though the screen was really easy to implement, I still had to write components. So if I were to recommend for my day job, I would say we are going to start with the components so that we can build good reusable components, so that we can build a library of components, so that when a team member then comes to a screen, that they have a library of components to choose from, and then the conversion to the screen is going to be easy. The flip side of it would be if they started doing every single screen, then I might get a mismatch of components. Each of the feature teams would build a screen and build the components they want the way they wanted to, and there might be a mismatch among screens. So to get reusable components, we're going to be starting with components first. And then the realm of the void, I would say that if you're considering adding Compose, it's probably a good idea to figure out what your architecture looks like and how things are, and to do some refactoring so that you've got a clear view of how your state will flow and how the events will update. Because Compose requires you to be clear about how you're handling your state. And Compose is not going to clean up the mess for you. In fact, it might probably be more difficult to convert into Compose if you've got a complex architecture and state flow happening inside your app. So what's next? So the Habitica app is not going to get my PR for Compose, and I will soon be fixing some memory leaks for them. The Luno app, where we are at the moment, is we've got starting of Compose inside the app, we've got some guidelines, and our approach is going to be components first. We are in the process of modularizing. We have some modules, and so it'll be a combination of composables inside modules and composables inside feature modules. And at the moment, we're not even going to go near navigation. We have a custom navigation implementation. And so we're just going to build the components and build the screens, and then keep our old navigation system to do our navigation. So this talk has many links in it. And I will share the slides on my Twitter, and you'll get all of these links of all of my research on the way. And with that, I'm open to questions if there's time. Let's see what the time is.